So as we continue with page 2, this is very similar to what I wanted for your quiz. The only difference is now you need to graph it. So it's opening up because of the 3. To get the axis of symmetry, that's what I'm doing in standard form, the formula negative b over 2a. So I'll put my a equals 3, b equals negative 6, c equals positive 6. So negative b over 2 times a, 6 over 6 is 1. That's the axis of symmetry. That's the x value of my vertex. Since it's going up, it's a minimum. Okay? Now to get my y value, I'm going to plug x in there. I kind of like that it's a 1. It feels easier. 1 squared is 1. 3 minus 6 plus 6. Negative 3 plus 6 is 3. So I got the y value of my vertex. To get the x-intercepts, I'm going to try to factor, so I'm going to make that 0. So 0 equals 3x squared minus 6x plus 6. I notice they all divide by 3. Since I'm solving, I can get rid of stuff. If I'm factoring, I can't just get rid of anything. I need to take it out and put it to the side. So I'm left with x squared plus minus 2x plus 2. All right, I can tell I can't factor that. I could solve it by completing the square. So that's one option, is I could complete the square. Another option is the quadratic formula. I'm actually going to do both on a separate piece of paper so that you can see what to do. So I'll start off by completing the square first. So let me write down the original problem, and then I can cover this up. All right, so I set it equal to 0, and then I move over the 2. So now I'm going to do my box. Half of 2 is 1. X, negative 1. X, negative 1. 1 times 1 is 1. So now I'm going to add 1 here, and I'm going to add 1 there. And then I'm going to take this x minus 1 and equal it to negative 1. I'm going to be doing an imaginary. So then I square root. X minus 1 equals. Well, what's the square root of 1? 1. What is it when there's a negative? It's an I. And then plus or minus. So I add 1 to both sides, and I get 1 plus or minus I. If I decide to do the quadratic formula, my a is 1, my b is negative 2, and my c is 2. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. You know I like dealing with this first. So that's the square root of 4 minus 8, which is the square root of negative 4. Square root of 4 is 2. Negative means I. So now I have 2 plus or minus 2i over 2. Divide all of them by 1. So I get 1 plus or minus I, which is the same thing. Okay? But I need to write it as a point. So I know I got this as an answer. Okay? So I'm going to write it as 1 plus I, comma 0. 1 minus I, comma 0. Now, let's say you had to do the quadratic formula, and you'd end up with 1 plus rad 3. Let's just pretend. And 1 minus rad 3. So if you got this as an answer, you would write 1 plus rad 3, comma 0, 1 minus rad 3, comma 0. If you wanted to get bonus, what you would do is you would go 1 plus rad 3 is $2.73. So this is 273, comma 0. And then 1 minus rad 3 is negative 73, comma 0. Okay? You would need to graph that, though. So if this was on a graph, let's just say, so I guess it's not really even bonus then because you kind of have to do it. So 273 would be here, and negative 73 is here because it's not quite $1. Okay, so just keep that in mind. All right, to get the y-intercept, you take 0 and plug it in for x. So it's 3. I know some of you know the trick, but I'm just going to make it show all my work. Anything times 0 is 0, 0, 0, 0, 6. The domain of all of them is all real numbers. Negative infinity to positive infinity. the range is y is greater than, because it's going up, take the y value of the vertex, because that's your y, 3, and then it's 3 positive infinity. If your answer was y is less than or equal to 3, then it would be negative infinity, positive 3 bracket. Just keep that in mind. If it was y is greater than or equal to negative 3, then it would be negative 3, positive infinity, parenthesis. And if it was y is less than or equal to negative 3, then it would be negative infinity, negative 3 bracket. Okay? All scenarios. Intervals. So in order to do the intervals, I'm going to do a rough sketch where this is 1, 3. This is negative infinity, positive infinity, positive infinity, positive infinity. Because the positive infinity means it's going up, intervals have to do with my x. So some of you forgot on the quiz, don't forget to state if it's increasing or decreasing. Down, decreasing. 1, increasing. Okay, end behavior. I'm going to do the end behavior over here. As x approaches negative infinity, f of x approaches. It's going up, so it's positive infinity. As x approaches positive infinity, f of x approaches, still going up, positive infinity. Now I need to graph it. Now it's kind of hard to see the lines, so I'm just going to fake it. 1, 3, done. I can't graph the x-intercepts because they're imaginary, but I can graph 0, 6. This is just like your project, where if you have imaginary roots, you can only graph half of that. So you have to make the other half perfect. So since this is left 1, this would be right 1, and the same y value, boom, and then draw the axis of symmetry. Okay? All right. Just as a side note, let's actually pretend this same thing, but it had 1, 3, I don't know, 0, negative 7, and then, so that would be 1, 3, 0, negative 7. If you notice, if it's, let's just pretend it was going down, okay? Let's say it was negative 3x squared minus 6x plus 6, okay? Then you would have to know that there are 2 x-intercepts that you would have to get on there. So it makes sense when this is going up that my x-intercepts are imaginary. It would also have to make sense that there would have to be 2 x-intercepts if it was going down. All right. They want to know how many answers am I going to get. Well, when I ask about that, here's an example of one real solution. It touches 1 time. It touches 1 time. And that's when you have like the square root of 0 is 0, so you get 1 in the quadratic formula. So whether you add 0 or subtract 0, your answer would be the same. 2 real solutions is when you get an answers like x equals 3 and x equals negative 4. Or you get 5 plus or minus 2 rad 3, because I have 5 plus 2 rad 3, 5 minus 2 rad 3. Another real solution is like negative 6 plus or minus the square root of negative 312 over 7. Negative 6 plus 312 over 7. I can calculate all, I can put all of these in the calculator and get a real answer. And there'll be 2 of them. Complex just means imaginary. So if I had 5 plus or minus 2i rad 3, it would fall in here. If I had x equals 3i, it would fall in there. If I have negative 6 plus or minus I rad 3 over 2, it falls in there. And you can't have a real one and an imaginary. It's like make up your mind. Are you real or are you imaginary? So what they want you to do is take this equation right here and figure out how many answers you're going to get. Well, I don't know if you've noticed, but it's all based on what's inside that square root when you're dealing with the quadratic formula. So I could do the whole formula if I want, but I know it's just this that I care about. So you can do the whole formula if you want, though, okay? 7 squared minus 4 times 5 times 1. 49 minus 20 is 29. I can literally pick up the calculator and take the square root of 29. So since I know that, my answer would be 2 real solutions. If I ended up getting, let's say, the square root of, I don't know, 63 minus 83, I would get the square root of negative 20. Boom, that's negative. That would be imaginary. 2 complex solutions. If I would get the square root of 16 minus 16, that's the square root of 0. Well, square root of 0 is 0. There's only 1 answer. That would be 1 real solution.